Hello students, welcome back. Now let's go to logarithmic equations. There are a bunch, and let's begin with the simplest problem here. And you'll soon see even the simplest is not that simple. Okay, here we go. We have this equation. Okay, let's call this solution 1. And of course, you can guess there got to be solution 2, maybe solution 3 as well. The first method is to combine logarithms and get a single logarithm and going from there. How do you do that? Log rule number 3 moves the coefficient to the power. And that's the same as, let's see, what is 1/2 power? That is square root, isn't it? So we have that equation. Okay, all right. Let's combine. Log of square root of x plus 2 divided by x is 0. So we have a single logarithm in the left-hand side. In the right-hand side, we just have a constant. Is it better? Yes, it is. It is indeed better because we can remove the logarithm by taking exponential of both sides. So if I do that, what do you get? E to the log of square root of x plus 2 over x, and that is e to the 0 power. Remember, exponential and logarithm are inverse of each other, so they cancel each other out. So we just have x plus 2 in square root over x is equal to 1. So we have square root of x plus 2 is equal to x. And then solving for x here, well, you can do that because this is an algebraic equation. Scaling both sides and so on and so forth, you can do this. I'll stop here, and that is solution 1. It works. It's not my favorite method, but it works. Oh, just one more step. Taking square of both sides. Okay, let's stop here. That's solution 1. Okay, is that the only way to work on? As a matter of fact, that's not my favorite method. That's not what I really like to do. And then before explaining the second method, let's go back to the general equation solving. And please remember the 3-step process. Denominators, parentheses, and like terms, okay? Now, this kind of problem here, combining the several logarithms into a single logarithm, it's more or less taking the like terms together. More or less. They're transcendental, so they are not the like terms in the algebraic viewpoint. But they kind of work like taking the like terms together into a single term. So, they fall in step 3. Denominators first, and that'll make this problem a little bit easier. We have denominator here, 2, so let's remove it. Multiply 2 to each term, so we have log of x plus 2, and then minus 2 log of x equals to 2 times 0, so there's 0. And then we work from here. Log of x plus 2 minus log of x squared is equal to 0. So log of x plus 2 divided by x squared is 0 by the log rule. And then we can take the exponential of both sides. Experienced students will skip this step, but let me write it anyway. Exponential and logarithmic cancel each other out, so we have just x plus 2 over x squared. And exponential of 0 is 1, so we get that. Flipping this denominator to the other side, we get x plus 2 is equal to x squared. Same equation as before, but we didn't have to deal with square root and all, so this is a little bit better, at least in my opinion. So we can factor those, and then we can find out, well, setting first factor equal to 0, x equal to 2, or x equal to -1. So we have these two solutions, or actually do we? As a matter of fact, at this moment, they're just candidates. The original equation is a transcendental equation. If it's polynomial equation, that's okay. If it is rational equation, still you must check. If it is algebraic equation with radicals, even there you have to check. This is transcendental, so most definitely you have to check. You cannot just stop here. You have to bring those back into the original equation and check. When x is equal to 2, it'll turn out okay. Wanna see? When x is equal to 2, then 1/2 log of x plus 2, 2 plus 2, minus log of 2 is 0, is that right? 1/2 log of 4 minus log of 2 is equal to 0. So log of 4 to the 1/2 power minus log of 2 is equal to 0. Wait a minute, what is 4 to the 1/2 power? That's square root of 4, so that's 2. It's okay. So this turns out to be okay. Or you can punch into calculator at this step here, and see if the right hand side is equal to 0. Yes, if you have something more complicated, probably that's a better idea. Now, what if x is -1? 1/2 -1 plus 2 minus log of -1 equal to 0. And even from here, you can already see something is wrong. Log of -1 does not make any sense. Or you can actually punch in the calculator. Log of 1 here, log of -1 here. Punch those in and then check your answer. You're going to get an error message. So this is extraneous. X equals to 2, only this one is legitimate. If you use solution 1, you can get up to the same polynomial equation here, and then you can solve the same. In the end, you're going to get both candidate, x equals to 2 and x equal to -1, and you'll have to go through this checking process the same way as well. Either way, it'll work out. Which method do you like better? The second method is a little bit better, at least in my opinion, because I don't have to worry about those radicals. Here's another method. Now this method is kind of a gimmick. It doesn't always work, so I pushed all the way over to method 3. But let's go ahead and do that. So from here, from the original equation here, one half log of x plus 2 equals log of x. Flipping log of x to the other side. It worked because we have 0 here. If I had anything else, this wouldn't have worked. So this is a kind of gimmick solution. For example, here it's not going to work. For C, it's not going to work, and so on and so forth. And then as for this problem, you can take, 1/2 power, or you can remove that 1/2. Either way, it'll work out. Let's remove it. Okay, here, still not ready. We have logarithm here. To the right-hand side, this is not really a logarithm, not just yet. We have this 2 here. I have to move it over the top. Now I'm ready to take exponential of both sides. If I take the exponential of both sides, then what do you get? Log and exponential cancel each other out. We get x plus 2 is equal to x squared. Okay? From here, I can do this. Taking exponential of both sides, we can remove this logarithm, and I get this one directly. Here, it doesn't work because there's an obstruction here. I can take exponential here because 2 is blocking somewhere in between exponential and logarithm. That 2 here is now moved up to the other side here, and that's why we have exponential and log coming one after another. I can cancel those out. It works now. So method 3 here works as well. We end up with same quadratic equation and same extraneous solution and so on and so forth. But there's a bit of a tricky part as well. And also this method is a little bit gimmicky. It's not going to work when you have some non-zero numbers on the right hand side. So this is not really my favorite method, but still, it works out anyway. We don't have enough time to go to any other method here, so let me open up the solution 2 once again and have a brief recap. Removing the denominator usually is the best idea. And then remove the coefficients. And then finally you can combine logarithms into a single logarithm. Here we have 2 logarithms. Combine those into a single logarithm. Yes, we can do that. If we have 3 logarithms, can we combine them into a single logarithm? Yes, we can, but if you do that, it's quite possible you're going to get cubic equation or something higher. If you have 4 logarithms put together, it could very well be quartic. So in practice, you're not going to meet those kind of complicated problems very often, if at all. Anyway, here we go, and please review. Okay, that's it. We are going to resume our discussion in a separate video.